All right, team, let's learn how to identify scientific variables. A variable is just something in an experiment that can change. And the prefix vary means to change. You can hear it in the word variable. You can hear vary. The variables are always written at the top of the t-chart or data table, and I always want you to try to visualize what the experiment is doing to collect data. So first, circle the variables, time and temperature. And then tell me in a couple sentences, like, what is the experimenter doing in order to collect data? So if you thought about that, you might say something like this. The experimenter woke up at 5, they went out with a thermometer and they measured the temperature. They waited 3 hours, they woke up at 8, and they went outside and they measured the temperature again. So maybe they want to see, how does time affect the temperature? And that's great. We're visualizing what's happening in the experiment. So a couple things. Let's just note that on the left, the experimenter changed the time. They could directly change that. They waited and they picked what time they wanted to go outside. And then the experimenter used a thermometer, collected data, and on the right side of this data column, we see the data that they measure, or the results. So most experiments in this class compare two variables. One variable is the cause of the experiment, and the other variable is the effect. So again, let's look over here at this graph. I want to circle the variables, study time and grade, and then tell me, which one of these variables do you think is the cause, and which one is the effect? If you said study time is the cause, then you're right, because study time, if you increase the amount that you study, you should increase your grade on a test or whatever. So study time is the cause and grade is the effect. And the reason why we're differentiating it like that is because in science we always have these two variables. One's the cause and one is the effect. And again, in a couple sentences, tell me, what do you think that this experimenter did in order to collect data? Okay, so maybe you said something like, the experimenter studied for 2 hours and then they measured the amount, they measured their grade on a test. And then they studied for 4 hours and they found that they increased their grade. They had a much better grade. So there we go. We're visualizing the experiment as we go and identifying the variables. So the scientific question should have the variables explicitly written within. Explicitly just means clearly, so you should be able to see it. Again, let's circle the variables. And many scientific questions are written with the following sentence frame. How does blank affect blank? So let's look here. We got a plant, and we have a scientific question. This is the SQ, the scientific question. How does the pH of the soil affect the height of the tomato plant? All right, take a second, circle the variables. So I'm going to do green for this first variable. I'm going to do a bracket instead of a circle. And then purple for the next variable, height of the tomato plant. Good. And so now our scientific question has that sentence frame. How does blank affect blank? Good. So what is pH? Just some background here. pH just means acidity, like lemon juice, hot sauce. Those are very acidic. Milk, not very acidic. So tell me in a couple sentences, what did this experimenter do? So maybe you said something like, the experimenter is going to put some acids or bases in the soil and measure the pH, and then they want to see if that, and then they are going to let the tomato plant grow and see if they change the acidity of the soil, will that affect the height of the tomato plant? So anyways, I'm just sort of thinking out loud here and trying to wrap my brain around what the experimenter is doing. So we have two variables. Tell me, which one is the cause and which one is the effect? If you said the pH is the cause and the height of the plant is the effect, then you are correct. We have a cause and effect. And that's how all of these go. So yeah. Really quickly, what would the scientific question be here? If you said, how does study time affect the grade? You're correct. If you look at this data table, Tell me, think about it for a couple seconds. What is the scientific question for this experiment? Maybe you said, how does the time affect the temperature? And you'd be correct. So good job. Okay, so now let's get into the definitions, because this is something that we'll need to memorize in this class. The independent variable and the dependent variable. The independent variable, let's start with. It's the cause of the experiment. It's the variable that the experimenter directly changes each test. And we write the IV on the left side, or the X column of the data table or the t-chart, and the horizontal or X-axis of a graph. Just add this to your notes. If you have a t-chart or a graph, you're going to write your independent variable on the left side and on the horizontal side of your data table and graph. So what is the independent variable in this experiment? What is this experiment? Take a second, pause the video, and tell me in a couple sentences what's happening in this experiment. What is the experimenter doing in order to collect data? So you see that this experimenter is looking at this heart monitor. It says 75 BPM, meaning beats per minute. So he's looking. He's got the subject of the experimenter here has a heart rate monitor on, and the experimenter is looking at their heart rate. But what's the independent variable? What is the experimenter directly changing? Well, in order to know that, you got to look down here. Jazz, hip hop, reggae, rock and roll. This experimenter is going to take different albums and put it on the record, and he is going to change the type of music. So the experimenter to the right is going to change the type of music each test. That is the independent variable. So take a moment here. If they're changing if the experimenter is changing the type of music, and that's the independent variable, what's the dependent variable? And can you put it into a scientific question for me in the sentence frame, how does blank affect blank? Can you do that? Awesome. So if you did this correctly, then you have something like, how does the type of music affect the heart rate? Good. So the next one is the dependent variable. This is the other variable. We have a cause and an effect. The dependent variable is the effect of the experiment. It is the results or data that is collected. The experimenter cannot directly change this variable. They observe the results of the experiment and measure the dependent variable to see if it changed from their last test. Okay, so let's look at this experiment. Tell me in a couple sentences what's going on here. We got Mentos, the fresh maker. We have the Coca-Cola spout is shooting out. There's a meter stick there. So if you said something like, okay, the experimenter is going to change the number of Mentos each test, and then they're going to measure the height of the spout, then that's a great explanation. You kind of have an idea for what's going on. So can you tell me what would be the scientific question here in this experiment? It would be something like, how does the number of Mentos affect the height of the Coca-Cola spout? Good. So that would be the scientific question here. Oop, I always forget my question marks. So we always write the dependent variable on the right side of the data table or t-chart. So here, let me write a little t-chart there and a little graph here. So we always have our dependent variable there and our dependent variable on that vertical axis. Many scientists differentiate the IV and DV by saying that the IV is what you change and the DV is what you measure. They're going to change the number of Mentos, and they're going to measure the height. So that's a great way to be able to differentiate it, using that definition. IV is what you change, DV is what you measure. So the experimenter to the left will measure the height of the Coca-Cola spout. That is our dependent variable. Good. All right. Workers at a company. So here's an example question, because you're going to see some problems like this on tests. Workers at a company were assigned to one of two conditions. One group completed a stress management training program. Another group of workers did not participate in the training. The number of sick days taken by these workers was examined for the 2 subsequent months. Subsequent just means following months. So tell me, what's the independent variable and what's the dependent variable? Take a second to think about it and then write it down. All right, if you're coming back to me after pausing the video and thinking about it, then you probably found the dependent variable first. It's the number of sick days taken by these workers. I'm happy that that's a number. It's quantifiable. Is the number of sick days. And then what's the independent variable? Well, it says here that one group completed a stress management training program and another group of workers did not participate in the training. So what did the experimenter change? Well, they changed whether or not their subjects completed the stress management training program. So they had a group that took the program and then they measured the sick days, and then they had another group not complete the stress management program. So that's what the experimenter directly changed, is whether or not, I don't know if I spelled weather right, whatever, whether or not the subjects or the workers took the stress management program. Good. So important materials are not variables. Materials are not variables. I didn't just say for independent variable, the stress management program. The thing is not the program, it's not the variable, it's whether or not they took the stress management program. The dependent variable isn't just sick days, it's the number of sick days. So in order to really nail this down, make sure that your variables have like a number or a value or a yes or a no assigned to it. Make sure that it's quantifiable, maybe. Viable. That'll really help. Again, for this one, how does the number of Mentos affect the height of the Coca-Cola spout? I did not say how does Mentos affect Coca-Cola. Materials are not variables. The amount of Mentos is, and the amount of height the spout achieves is. Cool. All right, last thing, very last thing. Constants are the variables that stay the same. They are the independent variables that the experimenter didn't choose and therefore must control and keep them the same each test. So we have this plant growth experiment. Remember, this is the one with the tomato plant and the pH. And in that experiment, if you're looking at plant growth, you can really pick all sorts of different independent variables to change. The experimenter could have changed the amount of water, the amount of light, the pH of the soil, the type of plant, the temperature, the type of fertilizer. The sky's the limit. They just were creative and they picked the pH of the soil. That's what they wanted to choose there. Now, what's important to note is that all of these other variables, amount of light, amount of water, type of plant, temperature, type of fertilizer, those are the constants. Those are the constants. These are the variables that they didn't choose. And so the experimenter is going to make sure that they don't change ever. They're always giving the plant the same amount of water, the same amount of light. They use the same type of plant. They keep it all at the same temperature. And they don't vary the amount of fertilizer. And just to finish this off here, the possible dependent variables they could have chose: plant height, leaf size, root length, plant mass, amount of seeds. They just happened to pick plant height. They just happened to pick plant height for theirs. But they could have chosen a whole bunch of different ones. So experimenting, really, there's always a lot of choice involved, but it's your job to control the constants, and there's always one independent variable and one dependent variable. And that is how we figure out the cause-effect nature of the universe. And as we answer those questions using scientific experiments, we start to figure out the truth and learn how